Okay, so we're getting ready to finish chapter 2 today. And one question that came up in the homework was, how do you prime factor this number? Now, remember, there were two methods. And one method, you had to think of what times what is 86. The other method is to just start at the lowest prime, which is 2, and start seeing if any of these will divide. And so because this is even, the last number is 6, it will divide by 2. And so it's good to just get this out of the way. So 2 goes into 8 4 times, and 2 goes into 6 3 times. Now you're left with 43. Now
Mhm.
you're wondering whether 43 can break down. Now, the question is, do you try a million different numbers? Or is there a limit to how many you have to try? And the answer is there's a limit. So obviously 2 will not go into 43. So forget that. 3, I'm going to check out 3. 3 goes into, remember that there was a trick about 3. You add the digits. So 4 and 3 makes 7. 3 does not divide into 7, or 3 is not a multiple of that. And so 3 does not go. How about 5? We can tell automatically, because if 5 divides it, the last number would be 0 or 5. So 5's no good. And we can look at 7, although we really don't have to. 7, is there any of the multiplications of 7 come out to be 43? And the answer is no. So the worst case scenario is if it was 7, if 7 had been divided into that, 7 times 7, this is the worst case, is 49. And our number is only 43. So I really only had to try these first 3 numbers. So let me try. So the bottom line to all this is, if these 3 numbers don't go into 43, there's no way it's going to reduce any further. Bottom line, 43 is a prime number. So your answer, 2 times 43.
Okay. It's just I got a little tricked up because it says like enter your answer, and it has like an example is like 2 to the power of 2 times 3. So I thought it had to be like to
Right.
the power of something times
No.
something.
Remember this example I just showed, this
Yeah.
one actually had multiple numbers the same. And so you were forced to do it, show the power, but there's no power here.
Yeah.
Yeah, there's no need for power. Anybody have anything else before I continue? Okay. Well, there's plenty of time to ask more questions, but the first thing that I haven't covered is the word of. The word of is a simple little word, but it has a mathematical meaning if it sits between 2 numbers. So this one is sitting between 2 numbers. And so if that's the case, it's interpreted as multiply. Okay? Now, if you see a sentence that's a word problem and has the word of in it, that may or may not mean a thing. But if it's sitting between 2 numbers, or what's amounting to 2 numbers, then it's a multiply problem. So this helps you figure out what needs to happen. So this is 2/5 times 35. Now remember, 35, the best way to do multiplication is to have simple fraction, simple fraction. So 35 would then go to 35 over 1. So the word of turned into multiply, 35 turned to 35 over 1. Now, if you cancel 5 into 35, you're going to have this answer. If you need to see it broken down, you would say to yourself, 35 is 5 times 7. And whether this method appeals to you or not doesn't matter if you're coming up with the right answer. So this is 2 times 7 is 14 over 1. But you know very well we like the simplest version. It's almost like we're trying to save ink. And so 14 over 1 is really 14. So that's our answer for that. Now, let's see. It would really help if everybody could get here on time. So I wanted to talk about the triangle really quick, and I want to draw it like this. The area is 1/2 times the base and times the height. And I want you to see drawn like this where the 1/2 comes in. This number times this number would be the area of a rectangle. This one, length and width. Can you see visually that this is really just half? So there's a visual component of that, but this is the formula. If you need to write it down, feel free. But in most cases, they draw it kind of like this. And maybe they have this is 12 inches and this is 5 inches. Let me bring this so you can see it. So it's still the same thing. It's the bottom number times the vertical height. And so this would be 1/2 times 12 times 5. Now 12 needs to be written as 12 over 1 and 5 is 5 over 1. And you need to reduce it now so your life is simpler. So 2 into 12, if you learn to cancel, you would 2 goes into 2 once, 2 goes into 12 6 times. Or doing it the way I did it the last problem. Area equals 6 times 5 would be 30. And although they're not making you write down the unit yet, you will eventually have to. This is 12 inches, this is 5 inches, and inches times inches is square inches. And so, like I said, this will come up later. And so for now, they're just asking you to write the number. Okay. So that's that. All right. Let's do a few word problems. What is 1/3 of the sum of 8 and 4? Okay. What I've been saying all along is when there's multiple things going, there's a third of something, there's a sum, and so on. What they say first is dominates the whole thing. So we're doing a third of something. So 1/3 times something. What's the something? It's this part here. It's the sum. And so I'm going to say the sum of 8 and 4. Now, the reason I put this in parentheses is in order to get a third of this whole thing, I need to put it in parentheses so I get the sum. So when you were forced to do this, 8 plus 4 would be 12. That's the sum. Then I need 1/3 of times, and you could then take it from there. 3 into 12 ends up being 4. So you don't always have to break it down into primes if you can see what's going on. So this is 1 times 4 is 4, 4 over 1. Happens to be 4. Okay. All right. Okay. We have a cooking problem. Let's see what we can do. A certain recipe needs 2 3/4 cups of sugar. That's the recipe. Okay. If the recipe is to doubled, how much sugar? Okay, so we need double. And so double is basically times 2. So the problem goes like this. See if it's going to pop up or not. Honestly, there. So it's 2 3/4 times 2. So both of these numbers need to be turned into simple fractions. So the first one, 2 times 4 is 8, plus 3, if you're writing notes. Like that. This is 8 and 3 is 11 over 4. This 2 needs to be 2 over 1. So this is, we still don't know how much sugar yet, but we're getting there. So this 4 is really 2 times 2. This is 2 over 1. If you like this method, if this is working for you, you could take out a pair of 2's, which would leave you 11 times 1 is 11, and 2 times 1 is 2. 2 into 11, I think what in this particular word problem, we need to see, I don't know how much sugar that is. This is 5.5 cups. How's that? So we knew this and we need to double it. Now, sometimes in the middle of a word problem, people get lost because the numbers are kind of ugly. They don't like the look of the numbers, and so they're not sure. So what I wanted to do is start with the technique that I use all the time when the numbers are kind of getting in my way. And I turn the problem into something that's real simple. So for instance, what if the recipe called for 2 cups of sugar and we want to double it, right? So double it is 2 times 2, which would be 4. Now, why did I do this simple problem? Because it clarified to me what had to happen. So this became although this was not the real problem, this was a simplified version of the same darn thing. And so it said clearly, take the first number and multiply it to 2. And so when you can't decide whether you add, subtract, multiply, or divide, this is one technique for figuring out exactly what has to happen, and then you work through the steps. That doesn't mean the real problem, will be as simple as this. This was real simple. But what this did is provide the framework, the plan for finishing the problem. Somebody else, let's see. Okay. Okay, here's a problem. This particular poll found that 3/5 of the drivers used cell phones when they were driving. That's not good, right? To lose your, given this statistic, how many drivers in a group of 65? So there's a group of 65. We want to know how many use their cell phone. You get the idea? It's a little stuck, but maybe it'll unstick. So back to the problem. 3/5 of drivers in general, based on a poll, said they use their cell phones while they're driving. Now, if a group of 65, how many of them would use it? So using this idea of 3/5, let's see if we can pull this up. Is it clear what needs to happen? What do I do with the two numbers? Can anybody say? I give you 4 choices: add, subtract, multiply, divide. What's the correct?
Multiply?
It is multiply. We want, and see here, it was right here. 3/5 of the drivers. Now the drivers in this group were 65. So this became the format of what needs to happen. You see, the drivers turned out to be 65 in this group. So this is 3/5 multiplied by 65 over 1. It is a multiplication. This is what told us that. And so that word of actually counted as multiply, because the number of drivers actually, even though it was in a word up here, they gave you the number of drivers. And so you work from there, and then 5 does go into 65, 5 into 65 once, 1 left over. 5 into 15 goes 13. So 65 is actually 5 times 13. I'm running out of paper, so I'm just going to finish this way. So this 5 and that 5 could be reduced and turned into 1. So now what's left is 3 times 13. 3 times 13 happens to be 39 over 1, which is 39. So that's how many of the drivers are risking their life on the road there. Okay.
Miss
Yeah.
Patterson, I caught everything except that very last step when you did 3/5 times 65 over 1, how you got
I
rid of.
ran out of paper.
Oh,
And so I kind of,
so it's 65
so
over.
65, I actually divided, I could tell because it ended in 5
Mm-hmm.
that it would divide by 5.
Yes, I got that part, but where you got the 39%, that
Oh,
was the part I
5
quite
times
catch.
13, and then
Uh-huh.
3 times 5, and then the 5s hit the dust. So what you have to do is multiply 3 times 13.
39. And then the 5 get canceled out because they're alike.
Because, yes, right. And so this method, basically, you're matching same for same, which appeals to some people.
Got it. So that's how the denominator was gotten rid of.
That's right. So it's 39 over 1.
It's 39. Okay,
39.
thank you.
Thank you.
Thank you.
Okay. So, oh my goodness. Okay, I'm going to ask again if everybody would try to come on time. I know occasionally you can't. I had a professor, I was driving 2 hours to class 3 times a week. And if you were a minute late, he locked the door. And I thought, holy mackerel, if I ever was late and he wouldn't let me in, that would have been so discouraging. I've never forgotten that. I'm going to do 2.5. I'm not threatening, I'm just asking for your cooperation. So 2.5 is about division. And as it turns out, division and multiplication are very close to each other. And so if I have 12 over 1 divided by 3 over 4, okay? So even though I see the 12 and I see the 4 and I'm thinking maybe I should do something, the answer is no. What I need to do is convert it into a multiplication table. And so the multiplication problem turns out like this: 12 over 1 multiplied. And when you multiply, what happens is these two reverse. So this is 4 over 3. This is the problem we do. And so until you get it into multiplication, there's no canceling, there's no reducing, it's stuck, but it's in good form. Notice it was plain old fractions. Now, don't be tempted to turn this one around. This is called the reciprocal, and this first number never changes, but the second number does. So let's finish this. So it's almost as if this was the original problem. And so 12 is actually what, 3 times 4? And I did 3 times 4 because I figured I could take out a pair of 3s. Okay, 4 times 4 is 16. Over 1 will be 16. So so when it's division, it's an okay thing. It's just, it has to be converted to multiplication. So once it's converted to multiplication, you do exactly what you did in 2.4. You look for common factors, you prime factor it or factor it a bit so that you can cancel a few things out, and there you go. Now, somebody might say, why did you invert it? Why did you flip that? And so if I had 4 divided by 2, I'm going with the simple version because it's so that we can see it. 4 divided by 2 is 2. But there's an equivalent problem that will also get you the right answer. It's the 4 stays put, the division turns to multiplication, and 2 over 1 becomes 1 over 2. So 4 over 1 times 1 over 2. In other words, this will not destroy the problem. It will convert it to a multiplication problem, which then we can do in the way we've already learned. And so this would be 2 times 2 over 1, 1 times 2, cancel, cancel, 2 times 1, it's 2 over 1, it's 2. Now, with division of whole numbers, we could have been done a long time ago and we had the answer. But as we get more and more fractions and mixed numbers and everything, we've got to have a system in place. And the system in place is to always work from the multiplication problem. So we're interested in reciprocals. So let's take a few. Here's the first one, 2/3 divided by 2. So this is clearly division. This is fractions. So we know we might as well take our 2 and put it 2 over 1 because we know we like simple fractions to do our computations. The very first number is copied every time. The division symbol turns into multiplication. And in order to do that, we have to flip this. And so this is going to be the reciprocal. So this is 1/2. Now it's as if this never existed and you're focused right here. You look to see if there's something I can take out. And I can definitely take out those 2s. Everybody happy with that? And when I replace them with one, that's 1 times 1 is 1. And 3 times 1 is 3. And that would be your final answer. Okay, so it's not that bad. Let's try another one. 4/27 divided by, you can see how this is, whereas the first problem I showed you was 4 divided by 2, this is a horse of a different color, right? This is different. Nobody's going to be guessing what that is. So we better have some sort of method. And the method is convert it to multiplication. We have simple fractions, which makes life as good. And so we go 4/27, multiply, reciprocal, 9/16. At this point in time, ignore this completely. In fact, I'll just make it so you don't even have to see it. And focus there. This is the problem. We converted it correctly, and there it is. And I'm seeing the 4 and the 16 has potential, and I'm seeing the 9 and the 27 has potential. So I'm going to rewrite this as factors. 4 times 4 is 16. I think that might be an okay thing to do. And if you see this one, 27 is 9 times 3. You can, without having to completely prime factor it, get this taken care of. I can take 1 4 out, a 4 on top, a 4 on the bottom. I saw the 9 that was common, so a 9 here and a 9 here. And if I can find anything left, I'll write it as my answer. 1 times 1 is 1. And 3 times 4 is 12. There's your answer. 1 divided by 12, 1/12. Okay. Now, could I have prime factored it? Yes. But did I really need to when the numbers were small and I could say 16 is 4/4? I could do it that way if I felt like it. Okay. All right. Now what? Let's try one with a mixed number. 3 1/5 divided by 4.5. Okay, well, that's a mess. There's no way you're going to be able to see an easy answer to that. And so we're going to first of all make simple fractions. And in order to do that, we will do this. 5 times 3 is 15 and 1 is 16/5. I'm going to keep it division until I've got this cleaned up. 2 times 4 is 8 and 1 is 9/2. Well, that's much better, really, because this is a good form to do a calculation. I'm then going to say, all right, I've got division. I can quickly make it multiplication. The first number is copied exactly. Division goes to multiplication, and this goes to its reciprocal. So this is 2, and this is 9. Okay, so this is where the real problem is. So we're focusing here. The mess previously doesn't matter. So I'm looking to see if I can find anything that reduces. The 2 and the 5 do not have a common factor. Well, for starters, the 2 is prime and 5 is prime, and so there's no way they have something common. But the 16 and the 9, I'm trying to think. 9 is made up of 3 times 3. So the only way this is work if there was a 3 as a factor in the 16. 1 and 6 is 7. 3 does not divide into 7. 7 is not a multiple of 3. This problem does not go any further. There's no common factor. You could break it down, but you would then say, "Huh, I've got nothing." Can you see it? Now, if you can't see it, you would break it down. But the truth is, it was pretty obvious with the 2 and the 5. And this was a good start because 9 was 3 by 3 and there's no 3s here. In fact, 16, if you divided it all out, would be a bunch of 2s. But I don't really recommend doing this but now I can see a bunch of 2s and a bunch of 3s, nothing cancels. So the truth of the matter is, I just need to multiply across. 16 times 2 is 32, and 5 times 9 is 45. When you've looked carefully to see if anything reduces and you say to yourself, nope, there's nothing left, then you can be absolutely 100% positive that this will not reduce. In other words, if it doesn't reduce here, it can't reduce here. So there's no use wasting your time fooling around with this anymore. This is a done problem. How's that? Now, somebody sent me an email about gas mileage. And I think the problem I remember had to do with this, and we're going to have to decide whether it's multiply or divide. The car gets 24.5 miles per gallon. Okay. So the question was, how many miles will it get with a half a gallon? Okay. The reason this is worth doing, especially after what we did earlier, is to turn this problem into a simpler version so that we're 100% sure what to do. Now, I'm convinced some people know what to do right now. Does anybody feel like they know what to do with the two numbers?
I have to multiply 2 by 24.
You have, it is a multiplication. Multiply what by what?
2 times 24 plus 1.
Well, we're going to, I mean, that's to make it an improper fraction, but I mean, how do we get the answer for how many miles? What are we going to actually do? What, we're going to multiply, we're going to divide, what are we going to do? That was your problem, by the way.
Yes.
Here's what I want to do, and this is a technique that I showed you earlier. Make a simpler version. Here's the simpler version. If a car gets 24 miles per gallon, okay, that's a reasonable amount of miles. How much will it get with half a gallon? Okay, this is a simpler version of the same thing. So 24 miles would be how, if you had 1 gallon, that's all you had, you could go 24 miles. If you only have half a gallon, how far would you go? You wouldn't go 24 miles, would you?
No.
How
It's
far would
12.
you go? You would go 12. See, a full gallon would get you 24 miles, but a half gallon would get you only 12. How did I get 12? This is what I did. 1/2 multiplied by 24. But our problem was actually 24.5. Do you see how this told me what needs to happen? I need to just flat out multiply the 1/2 times that. Now, you're right. In order, once you figure out what has to happen, you then do the steps. But the important thing is figuring out what on earth you're supposed to do. And I had students, I used to have a book and the answers would be in the back of the book. And the students would say, oh, I couldn't figure out what to do. So I added, subtracted, multiplied, and divided until my answer matched the back of the book. Well, I don't want you to be doing that. One, you don't have the answers. And two, that's not a good plan. So it's 1/2 times this. So you were right that this is going to be turned into a simple fraction. So 2 times 24 is 48, and 1 makes 49/2. Okay, so I've got it as a multiply problem. It's a 1/2 times this number. I look to see if I can do some reducing, but 2 does not go into 49. So I'm stuck and I just multiply across. 1 times 49 is 49 and 2 times 2 is 4. Now I'm thinking, I'm not really sure how many miles I'm going to get. So with word problems, I think we're tempted to turn it into mixed numbers, and they may actually say so. Let's have your answer as a mixed number. So this is 49 divided by 4. 4 into 49. Let's see. 4 goes into 4 once. 4 goes into 9 twice. 2 times 4 is 8. And 1 left over. So the answer is 12, remainder 1 over the divisor 4. And the answer was in miles. Does this make sense? When you have 24 miles for 1 gallon, you only have 1/2 gallon. Does this seem right? You'd only go half as far.
My only question is, I don't understand why when we did the 1/2 times 49/2, why this time the second fraction wasn't switched to be 1 times 2.
Ah, good problem. We were talking about division, but this was a problem that actually was in the multiplication section.
Okay,
And when it's multiplied, there's no inverting. It's,
oh, so only if it starts off being a division problem would we,
that's exactly right. I'm glad you
Thank
asked
you.
that. I'm glad
Thank
that's a good question. How's that? So
yeah, that makes,
division gets flipped. Multiplication is perfect the way it's way it is. Good job. Okay. So how's our time? So let's take a peek. Has anybody tried anything else now that they're thinking about it, where they think they may have trouble?
For me, I have trouble getting to do the word, like to open it, if that makes sense.
You mean the technology? You can't open the problem.
Yeah, I can't open it.
We'll have to work on that individually. That's a technology problem. Does anybody have a math problem that they've tried and didn't work out? And I'll help you. I think
Okay,
I
okay,
recognize
thank you.
her voice. Who is it? Was it Hermela? No.
Yeah, I'm the one who had a
Okay.
problem.
I recognize your voice already and I can't even see you, so. Anybody have anything else that, so I'm gonna take us over, I wanna take us over to XYZ. There we are. Okay. So I'm hoping you're seeing that these are the recordings and you should be able to access them if you miss a class or you need to look at something again. So I'm going to stop the recording in a minute. The other thing I want to call your attention to is the calendar. So here we are today. This is the one in orange. And so I've actually talked about all the sections, 2.3, 2.4, and 2.5. So 2.3 is due tonight. You could use a late pass if you can't finish on time. And 2.4 and 5 are due Friday. So that's what you need to be doing, is getting that multiplication and that division that we talked about today, which is just an adaptation of multiplication. Get that done. On Monday next week, so that's the 17th, we'll be doing some review. Now, somebody asked about this, and I hope you can see this. When I click on this date, the Tuesday, it's a chapter review. And so I want to click on it and show you. So it's a whole bunch of problems, different problems from what we have done already. This one's using exponents, and this is order of operation. This was in chapter 1. And so there's a whole bunch. And so you just work through these. And then let's go back. Go back again. Then there's a chapter 2 review, something we were just working on. This is actually a good problem. 14 divided by 1/2 quantity squared. I think I'll do that in 1 second. But then there's all kinds of problems here for you to work through. Oh, that crazy number line. Fortunately, this one is 7/8, and you count them 1, 2, 3, 4, 5, 6, 7. The answer would be here. Like that. So that when the number of marks and the fraction match, then you're in good shape. But that's something you can work on anytime. Back to the calendar. Let me just get out of that. So you can do these reviews and see then what I'm talking to you about. Somebody needs to turn off their mic. For the first test, we'll just do it during class time. So it's important that everybody comes on time. And so it'll be more like maybe 10 questions. So it's not going to take forever, maybe 12, something like that. But it's plenty of time to finish. And then we'll do, that will be our class time. So you'll come to class and I'll give you a password that will let you open up the test. And then you'll do it during class time. And it's necessary to turn your video on. So it's almost like we're sitting in class doing a test. And so that's the way we will do that. And then when you finish, you can just leave. So if you finish early, life is good. Okay, I'll talk more about that on Monday, But it sounds like a test, but it's really kind of a simple thing. But I definitely want you to be aware that you want to finish up this work. You can start the reviews anytime this weekend if you like, get some of that done, and have it done by Tuesday night so that then you're ready for Wednesday, the day of test one. So we want to get that done. Any questions about that at the moment?
Yes, I'm curious about the reviews. Are those assignments kind of like the rest of our assignments in the XYZ?
Absolutely. So
Okay,
notice all I did was I clicked it and then it's the same the darn thing.
okay, okay.
Okay, so let me get out of this. I want to stop the